Evening, everybody. My name is Thor from Iceland in Motion. I'm going to explain activity for you and welcome to all the newcomers. So this is both current activity and explanations for newcomers. So there are multiple ways to access data for activity through apps and websites. So okay, this is my tour. I'm just going to go to Space Weather Live. It has information on everything we need. So current activity is, we can see this is a space satellite that measures the solar wind speed. So northern lights, they originate on the sun, and from the sun there is a constant stream of solar wind. Solar wind is composed of electrically charged particles. And this measures this is the speed of the solar wind. 400 is like steady average. Density, this is like, 2 till 5 is like a steady average. Interplanetary magnetic field, BT, this measures the average strength of the magnetic field. So the solar wind has a magnetic field, so that's the interplanetary magnetic field. Most importantly, what we are looking at is this one called B zeta or BC. When the magnetic field of the arriving solar wind is positive, it's being repelled by Earth's magnetic field, which is also positive. Just like two magnets, two positive magnets, they can't connect together. However, when it's negative, it's the opposite. So negative magnetic field of the arriving solar wind will connect to Earth's magnetic field, which is strongest around the poles, both the north and the south. So when it goes negative, it's drawn towards the poles, and when the particles are up in the upper atmosphere, they will collide with nitrogen and oxygen and start to glow as we see as the northern lights, called ionization. So ideally, we want this to be red or negative, and ideally a little bit deeper than it shows here. So these stats we have now, these average stats mostly positive, a little bit negative, will will generate northern lights, but usually not strong ones. And now I want to explain a little bit what happens when this goes negative. I want you to think of northern lights as an event, like a 3-hour event. When this goes negative, it creates the event. And the event starts with a build-up. In the build-up, the northern lights are generally faded. You can maybe see them, but they are not vivid as you see on the photos. Far from it. Sometimes they're not even visible. However, after a little while, when the build-up has reached its maximum, it will turn into peaks or highlights. When the northern lights are on their peak, they will become more visible, and sometimes you will see them moving, and that's when you also can see maybe different colors, or they will become much stronger than before. However, the peaks are usually rather short, maybe sometimes just 5 minutes, sometimes half an hour, sometimes 1 hour. After the last peak, there can be like a few peaks inside each peak period with little intervals of maybe a little bit faded. Then they will go into recovery. If the magnetic field is like constantly negative, another event will start. So there is on average 3 hours between the peaks. Sometimes not enough of the particles get in, so sometimes the peaks don't really come through. So we need enough of the particles to be able to get into the build-up for the peaks to happen. I can show you here, for example, on Glendale app. This is my favorite app. Explain to you a little bit. There is a graph here, substorm strength. This event on scientific community is called the substorm. You can just call it Northern Lights. So I can see, here I can see the peaks for previous nights. So around 10, there was a peak yesterday. That I can confirm. Like maybe it happened a little bit earlier, or the build-up was a little bit earlier, but the peak was around 10 o'clock. Then it kind of went up, but you see it's kind of on the yellow line here. So it never really got into another peak, but it just kind of stayed up. Like there were probably visible lights, but quite faded all night. So often when conditions are like constantly favorable, we would have seen the next peak 3 hours later, like 11, 12, around 1 a.m. And then if conditions would have been continuously favorable, it would be like 2, 3, at 4. So this is how I sometimes can predict the peaks. So after I know when the first peak is, I can understand the next one. You see, like on the end of the graph, like it doesn't show the whole graph. Let me show you. Maybe like here, you see there is like a little peak here. This is maybe around 7, or between 7 and 8. So it's 7, 8, 9, 10. You see, 3 hours between. So this is how we sometimes understand the peaks. But if it's just constantly positive, or there is no substorm happening, they don't. Sometimes they just they don't really materialize into anything. But this is the rule of thumb. Okay, so let's go back to Space Weather Live, and maybe an easier explanation is sometimes like, I sometimes describe this graph here as a door. When it's green, the door is closed. When it's negative, the door is open. So let's just tiny bit negative. There is just a tiny crack in the door. So just tiny bit of the solar wind can squeeze through the door. But let's imagine this going like let's say 10 and 20. This goes just like deep down. And then the door is wide open. And if it's green and goes deep like this, then like 1.5 hours later, we will start to have lights and potentially peak. I know everybody is now like waiting on the recent solar flare. So we had on the sun. I'm going to show you here. This here. This is the big one. Like yesterday, this spot was here, and on Sunday it was here. On Sunday morning, it created an X flare. X flare is the biggest type of flares. They are measured like, for example, C 1 through 9. Then there is M 1 through 9, and then there's an X 1 through 9. And this is like the earthquake scale. So there's a huge difference between like C, M, and an X. And we had on Sunday morning we had X1. On yesterday we had X2, and today we had X5, which is huge. However, because this is on the sun, there is a arrival time. We don't know how fast this is moving, but it's usually around 2 days. But the X flare on Sunday, he was apparently slower, but he has a head start of the one yesterday. The yesterday one is faster, and when they arrive, they potentially will arrive combined, and we call that a cannibal flare. Some indications, or some people say it might land tonight. I would say most likely tomorrow, but nobody really knows. So we only know when it passes the the satellite which measures the speed. And what will happen on this thing here, we will see when it arrives that this will spike up till maybe 800, and especially in the beginning the density will be just like 50 or something, and most importantly this here could drop like very deep, like maybe negative 50 potentially, and it could stay. It could also be, if it's a positive alignment, then it could be very high here. I would still say, like, if it's a super flare and if it's positive, probably something is going to get in and we're going to see good lights, but we want it to go negative, and potentially it will be going like up and down a little bit, but until that comes, we are not in any special conditions. We might have lights, like a little bit of lights, mostly on camera, maybe a little bit visible at peaks, but unless these solar flares arrives tonight, we are in just average conditions. Yeah, that's what we need. So just remember, like, we need this to go down. Remember the event. It creates an event, and it's important to get the peaks. You might be out and you say, why don't I see anything? It's because you're seeing it when it's not peaking. One other thing is locations. I'm gonna go to my location map, my maps. Let's just take a look at my main map. Where is that? So it has a lot of locations. So let's imagine the sky is clear around all Iceland. At the same time, we are seeing the same lights. The only difference is if you are in northern part of Iceland, you are seeing the lights a little bit higher higher up in the sky. If you are, let's say, in Reykjavik, or you're in Vík, or you're in Glacier Lagoon, and you're seeing the lights, let's say, like 45 degrees up from the horizon, that means those in the north are seeing them maybe 75% up from the horizon. That's the only difference. You're still seeing the same lights. There might be a slight difference in the angle from when you're in the east or in the west, but I have seen, I've taken a photo of the northern lights with a very specific shape when I'm here in Reykjavik, and somebody else took a photo in Höfn, and it had the exact same shape at the same time. So locations are mainly cloud dependent, and also, like, it's good to go out from you can see very good northern lights. You can see in Reykjavik city, especially when they're like overhead, but that's just like watching a great movie in a theater with the lights on or lights off. It's going to be better to have the lights off in the darkness. Other thing to mention, if the lights are like low on the horizon, if you're close to a big mountain, the mountain can block the light. So I usually, when I'm going out on a tour, I try to locate myself a little bit away from a mountain or on the north side of it, especially when I think lights may be low on the horizon. Other than that, mainly what we do when we are searching for the northern lights, we drive out, we park where the sky is relatively clear, and then we just wait. If the sky is clear, you're not going to see lights any better with moving. Everybody's seeing the same. So it's just waiting patiently and getting the peaks. Be outside ready when the peaks happen. That's the main thing. Although when I put locations, I usually put a location where you can kind of park safely. Try never be like parked on the main road. And for example, when the solar flare is landing, when I know it's landing, we are very likely to be seeing the lights even in the south, looking south, above us to the north, and also to the south. Because if a huge flare lands, the solar wind is being drawn in, and so much of it will come, it will spread further south. So might even be low on the south horizon, probably very red, maybe also above us. So I will try to find locations which are also suitable for looking south. Most of these locations on the map, they are suitable for looking north. So for example, when we are driving, like, let me see, when we're driving uh, uh, like off the roads here towards the national park, I try to be not very close to this road here because all the traffic is going to be driving here. So if we are parked just like by the road, we're going to have all the traffic of the cars blinding us. So unless we go a little bit further away, that's okay. But generally we have the locations on the north side of the road. So let's see. Yeah, it should be like that at least. Uh, so I'm gonna put just some nice locations where I think maybe not everybody will be. But when you go, if you go out and you're driving and you maybe there's a 45 minutes to a location, if you see the lights are already pumping, you just find some exit of the main road and just park your car there, and you're just as good as the location I sent you. But let's see how tonight works out. I'm gonna update you also like through the night regarding the activity. As of now, it's calm, but we have an X factor. It might the solar flares might arrive. They could arrive in the morning. So like if you're prepared to wait, then you have nothing else to do. It's worth waiting for it. If let's say the land like 3 in the morning, that's going to enable lights like 1 hour later, and they're likely to be very, very good.